Recall that the standard form of a circle in the coordinate plane looks something like this. X minus h squared plus y minus k squared equals my radius squared. And h comma k represent the coordinates of the center, and r represents the length of my radius. So if I'm trying to identify the center and the radius from an equation, notice no number is being subtracted from x or y here. So that would lead me to conclude that my center is at the origin, 0, 0. To get my radius, I just take the square root of whatever that last number is. If it's a perfect square, good for me. If not, I could leave it as a radical. So for that first equation, the center is 0, 0, and the radius is 4. For an instance where I do have numbers, a quick rule of thumb is that I could just take the opposite sign of what I see. So if I see minus 8, my center is at plus 8. If I see plus 3, my center is at minus 3. And again, my radius is the square root of that last number, or just 10. So all of these follow suit with that. Like even for C, my center coordinates would be -2, -7 if I were to plot that, and my radius would just be 7. So keep that in mind. For number 3, which of the following points would not fall on the graph? Well, this is a different type of question where algebraically, if a point, like let's just say 6, 8, if this is on the circle, then when I substitute in 6 for x and 8 for y, it should satisfy that equation. So let me check some things here. All right, 6 squared is 36. 8 squared is 64, and I want to see if that's equal to 100. And if I add 36 to 64, bingo. So that point is on the circle. So the strategy here is to go through each of these points to find one that doesn't satisfy the equation. Some things to be careful of is that when you plug in a negative number, make sure you're squaring that whole negative number, because a negative squared should be positive. And if you go through all of these, you'll realize that if I take 8 squared plus 2 squared, and I see if that's equal to 100, well, you might already see where this is going. 8 squared is 64, plus 2 squared is 4. That would just be 68, which is very much not equal to 100. So that's the one that would not lie on the graph of that circle. Graphically, to find the center and the radius, you kind of have to estimate where it is. And let's say I thought the center was at 4, 3. Let's say that's where I think the center is. Well, the center should be equidistant from all the points in the circle. So if I count real quick, 1, 2, 3, 4, 5, 6. It's 7 up to get to the top of the circle. 1, 2, 3, 4, 5, 6. 7 down. 1, 2, 3, 4, 5, 6, 7 to the right and 7 to the left. Looks like my radius is 7, and that 4, 3 is indeed the coordinates for the center of my circle. So that 4 represents my h, and that 3 represents my k, and 7 represents my radius. So when I go to substitute into x minus h squared plus y minus k squared equals r squared, I've got all the pieces to plug in. My x is 4, my k is 3, and my radius is 7, and 7 squared is just 49. So this would be the equation of my circle in standard form. Now part C asks how many times would the line y equals 10, which is just a horizontal line at a y value of 10, how many times would that intersect the circle? Justify. Well, it looks to me like it intersects exactly once at the top there, and that's because y equals 10 is tangent to the circle. Remember that a tangent line has exactly one intersection point with the circle. If it went through, like a secant line, that would have 2 intersection points. Number 5. The center of circle Q has coordinates 3, -2. If circle Q passes through R, which is at 7, 1, what is the length of its diameter? Now that word length is a key word that's telling me I might have to use the distance formula here as I'm going through this. So let's try to visualize this. I've got some circle, and I know the center point is 3, -2. And I know some point on the edge of the circle is at 7, 1. They want me to find the length of the diameter, which would go all the way across for the circle, but I only know the center and one of my endpoints. So the strategy is plug into the distance formula to find the radius, and then just multiply it by 2 to get the diameter. So remember my distance. If I label one of my points as x1, y1, and x2, y2, it's the square root of x2 minus x1 squared plus y2 minus a -2, which is going to be plus, squared. If I evaluate that in my calculator, the number under the radical is 25, so the distance here is 5. Now look at that nice answer choice right there that's staring you in the face. I want you to read the question one more time and think about what this distance represents. I want to find the diameter, and that distance we currently found is the radius. So my whole diameter would be twice that length, or 10. So just keep that in mind. Now, number 6 is a very similar scenario with a diameter that has endpoints -2, 1, and 6, 7. So you've got some circle, and you know the endpoints of the diameter. If you wanted to find the center coordinate, the center is just right in the middle of the diameter. So the strategy is to use the midpoint formula, which is the average of the x's, comma the average of the y's. So if I substitute into that, if I add my 2 x values for the endpoints of my diameter, and the 2 y values for the endpoints of my diameter, I find that that midpoint, let's see, -2 plus 6 is 4, divided by 2 is 2, and 1 plus 7 is 8, divided by 2 is 4. So that's the center coordinate there. Now to find the length of the radius, I'm not going to use the endpoints of my diameter. I'm going to use one of my center point, and one of the endpoints. It doesn't matter which one you use, because the radius should be the same length on either side. So I'll pick 6, 7 as my other point. Again, this is going to be a task for the distance formula, given that it says length. So if I label one of my points as x1, y1, and my other point is x2, y2, I could substitute into the distance formula again. Remember, that's x2 minus x1 squared plus y2 minus y1 squared. And if I go to simplify that, let's see, this is going to be 16, again, that's going to be, let's see, 3 squared, 9. It's going to be radical 25 again, and I find that, lo and behold, my radius is 5. So when I write the equation of the circle, again with h and k as those coordinates 2 and 4, it would be x minus 2 squared plus y minus 4 squared equals my radius squared, which is 25. Now, sometimes I won't have my circle in standard form already, and I need to do a process called completing the square. The first step is always going to be to move the constant to the other side. So I've got -8 on one side, because if I want to get rid of a +8, I could subtract it from both sides of the equal sign. And I'm going to rewrite it a little bit so that my x terms are together, and there's a space after my x to the first power term, plus y squared plus 16y, plus another space right after my y to the first power term. And the process of completing the square goes like this. I'm going to look at what I'm going to call my b terms, or my linear terms here. You're going to take half of it, square it, and add it to both sides of the equal sign. So let's see, half of -10 is -5, and when I square -5, I get +25. If I add that to one side of the equal sign, I need to make sure to add that to the other side of the equal sign as well. And I could do the same thing for my y term. Half of 16 is 8, and 8 squared is 64. So that's what I'm going to add here, and that's what I'm going to add here. So at this point, my right-hand side simplifies pretty nicely. If I add -8, 25, and 64, I just get 81. And the whole reason we completed the square and did this process is because it makes these trinomials nice and factorable. So let's just take a look at x squared minus 10x plus 25. If I were to just look at this trinomial and factor it, I'd ask myself, what two numbers add to -10 and multiply to positive 25? Well, for positive 25, I know 5 and 5 would multiply to them, but to get them to add to -10, they could both be negative. So I write two sets of parentheses, x in the first part of both of them. One of my factors is a -5, and my other factor is also a -5. With completing the square, that should happen every time, such that instead of x minus 5 times x minus 5, I could write this as x minus 5 squared. Now I could do the same thing for the y's. What two numbers add to 16 and multiply to 64? Well, that would be 8 and 8. Or I could rewrite that as y plus 8 squared. The benefit of doing this process is now it looks like the standard form of a circle, right? It looks something like this. So if I want to identify my center point, it looks like that's just positive 5, comma -8. Remember, I take the opposite sign. And my radius is just the square root of 81, or 9. So this would be the equation of my circle. And this down here is the information I could gather from it. If you want a quick trick, and you feel like you might forget factoring, what you could always do, you could take a look and jump right there. And you could ask yourself, what's half of that b term, -10? Well, half of that's -5. That's the number that's going to appear in the parenthesis there. You can do the same thing for y. What's half of that linear term or that b term for y? Well, it's half of 16 is 8. That's the number I see there. That is always going to be the case if you want to jump after you've completed the square to that x minus 5 squared step. So if you wanted to skip that factoring in the middle, you always could. B is going to be almost the exact same process, but there's a couple of things I notice here first. Number one is that they've already moved the constant to the other side, but also completing the square only works when there's a coefficient of 1 out in front there. But it looks like everything is divisible by 3. So I'll start just by dividing all of the terms in my equation by 3. So 3x squared divided by 3 is just x squared. 42 divided by 3 is 14. And 12 divided by 3 is 4. Now I run into another issue where my x's and y's are separated. So I'm going to rewrite it so that my x's are grouped together. So my 14x is by my x. I'm going to leave a space after there. Plus y squared plus 4y. I'll leave a space after that as well. Equals 11 plus blank plus blank. And you would go through the same process. You'd look at 14. Okay, what's half of 14 and what's that squared? Half of 14 is 7. 7 squared is 49. So that's the number I'm going to slap there. But what you do to one side of the equal sign, make sure to do it to the other as well. And then 4, well, half of that is 2, and 2 squared is just 4. So that's the number I'm going to add next to the y and over there as well. Now when I add 11 plus 49 plus 4, I believe that's 64. And again, if you want to jump straight to, okay, now that's going to be x and something squared, y and something squared, and I could just look at my b terms and say half of positive 14 is positive 7, and half of positive 4 is positive 2. That's okay as well. And we can gather that our center point is -7, -2, and our radius from that is 8. It's not always going to be a perfect square. Sometimes we'll have to simplify, but in these cases it happened to be the case. Number 8. Given circle O with that equation, use the process of completing the square twice, that's what we just did, and write this equation in standard form. And what are the center and the radius of the circle? So this is a process that we just did. So I'm going to walk you through. I already have the solution written out. I want to talk about what this would look like. So here's the scenario. I've done completing the square already, and I found my center to be 2, 4, and my radius to be 5. And I sketched the circle to the best of my abilities over here. Now, mine was pretty good because I have a computer to use, but yours doesn't have to be perfect as long as it gets the idea across to plot 5 up from the center, 5 right, 5 down, 5 left, and so on. Now, given point -2, 7 on the circle, find the slope between point A and the center O. Because our goal is going to be to write the equation of this tangent line, and remember that a tangent and a radius are always perpendicular. And perpendicular lines have negative reciprocal slopes. So if I count, let's see, to get from A to O, I'd have to go down 3 and right 4. So the slope of my radius AO is down 3 and right 4, which would mean the slope of something perpendicular to that, if I take a negative reciprocal, if I flip the fraction and change the sign to positive, this is the slope I would care about for the equation of a tangent line. So that's part E down there. I'll write it over here for the equation of a tangent line. So generally, point slope form is going to be the easiest to work with. And point slope form just looks like this. All you need to write the equation of a line in point slope form is one point on the line. That's what x1, y1 represents. And if I'm looking at my graph here, I absolutely know a point that's on the line. I know that's -2, 7. And you would also need to know the slope, which, again, since it's perpendicular to the radius, I already know that's 4/3. So it's just a matter of substituting in those pieces. So I'll plug in here. Y minus my y coordinate for the point I'm looking at is 7 equals my slope, 4/3, times x minus a -2, but of course I could just write that as +2. So that would be the coordinate, or the equation of my tangent line in point slope form. Now, it doesn't say I need to find the y-intercept here, so this could be a perfectly good way to write it. Because even if you look in your graph, it doesn't look like it's a nice y-intercept anyway. So you don't need to solve this y. This would be perfectly acceptable to leave it like this. All right, now for the last one, number 9. This is another completing the square question. It says, that's the equation of the circle, determine the center and the length of the radius. And I'm going to need to complete the square again, and I'm going to start by moving the constant over. But the problem is I don't have any other x terms, right? It's just an x squared. So I'm actually going to leave him alone for now. And I'll just, since I've got a second term for the y, I'm only going to need to complete the square once here. Even as I'm looking at my answer choices, I notice that all of my center coordinates are 0, which is always going to be the case, when I just have an x squared. So that's telling me, leave that, don't worry about them, just complete the square for y. All right, well, I'm going to look at my b term. That's -6. I'm going to take half of that, square it, and add it to both sides. Half of -6 is -3, and -3 squared is a +9. So I get x squared plus, and again, I'm going to use my trick one more time. I'm just going to take half of -6 to be -3. And here's my equation of the circle. -1 plus 9 is 8. Okay, so by process of elimination, I know my center point is 0, +3, because I take the opposite sign. And the only answer choice that has that is 0, 3. But how did they get that radius of 2 radical 2? And the answer to that is that this number represents my radius squared. So if I take the square root of 8, here's the equation I think about. That number represents my radius squared. So if I wanted to solve for my radius, I find that my radius is just radical 8. And if I wanted to break that down a little bit, I'd ask myself, what perfect square divides into 8? Remember, the perfect squares are like 4, 9, 16, 25, because that's 2 squared, that's 3 squared, and so on. And I know 4 is a perfect square that divides evenly into 8. 4 times 2 is 8. The reason I'm doing this is to get the number that's left under the radical to be a little bit smaller. Now, I know what the square root of 4 is. If I type that into my calculator, it will tell me the square root of 4 is the same thing as 2. So rather than writing that as radical 4, I'll just write that as 2. And I don't know what the square root of 2 is, so I'm just going to leave that. So in simplest radical form, radical 8 is just 2 radical 2, which is how we get that radius there. So in some instances, we will need to simplify a radical before we do anything else.